software engineer, programmer working at Jemmic. I've worked in several fields doing software. Cadastral land registration systems was one. I've done some mobile and web development. I've worked for most of this time, not necessarily, but several years, on a strong authentication software. That's my main job at Jemmic. And I also worked for about 3 years at a big e-commerce website that's also legally based here, named after a rainforest. And I think there's one other person here that works there. But, yeah, so what I wanted to talk to you about today is how can I choose a good library? Because I've been suffering through some choices that we've made that not only I have made, but other people have made in our code base, and I've been thinking about this problem a lot. So, yeah, it's a hard question. And first, think about when you are going to choose a library for your project. What do you look at? The common one that I see is people like to look at the stars, because those are always true. It's not fake. There aren't bot farms, and you can't buy those. But another common one is how many days ago was the last commit? Is it active? Is the author alive or dead? Issues and requests, maybe, maybe not. You know, that's a bit more subtle. Is it because it's a lot of problems, or is it because people have a lot of things they want to do? It's really hard to tell why there are issues, but you may look at that. But there's a lot of criteria, and it's kind of fuzzy, right? So I find that this question, as I thought about it, this question also has a lot in common with that question about, yeah, how can you build a good library? And so I'm going to explore answers for that. And you can't, sorry. It's impossible to build a good library, yes.
So have you ever built a library yourself? Maybe you asked for it later.
Let's not go there yet, but I'll go through a few anecdotes for sure. But yeah, sorry, that's my conclusion. You can't. It's all impossible. But no, more seriously, it's really hard to build a good library. It's not impossible, but when you do it and fail, you shouldn't feel bad. And yeah, so how can you not write a good library is an easy question to come up with answers for, because maybe some of you have suffered through bad decisions before. So one way is have a lot of dependencies. Don't think about how complex it is. Think npm left pad. Think is even, is odd. You know, throw in another library. It's just 10 lines of code, but it's okay. Why is this problematic? At one of the companies I was working at, our dependency graph looked similar to this. Just packages depending on packages depending on packages. And we had class path conflicts with a wonderful library by Google called Guava. I'm not dissing on Guava. It's got a lot of useful stuff in it. But if you depend on version 33 and he depends on version 22 and the other's on 26, good luck. And maybe he needs it, and maybe he relies on some specific behavior of 22 that your 33 breaks. It's hell. And when I was detangling this mess, I would often find that they were just using it for immutable map. Like, no, there is a perfectly good unmutable map in the standard library that you should have used. But especially if you're a library and you're sitting at a foundation of something. But anyway, this is another one that I'm suffering through now. It's a lovely build system called Gradle that changes their mind every year or two and re-implement the API. They change the way you're supposed to build your tasks. This was if you go look in the tutorials online, this is the one that they use, but then they changed this one a few years, and now they're adding this new task configuration cache that broke our instrumentation, and it broke IntelliJ's integration as well. I don't know what they're doing. I don't know what's going on. They have a lot of good things. That's why people use it, but they're just moving too fast and not thinking about the impact that they have. And that's a bad decision when it comes to libraries, and something that we should think about when we build our software. Another one, don't care about performance. That's how you get a really good library. So why? You can think, oh, I'm not counting nanoseconds or microseconds. I just count seconds because my performance doesn't matter. But when you're making a library or when you choose a library, the performance characteristics of that will make other things downstream possible or impossible. And you don't know how they'll use it. You don't know what they think, what their use case is. So just shaving those things down and keeping it slim and efficient is very useful and good. So there's several dimensions to this performance problem. One of them is very popular now to think about and made fun of everywhere. You know, your node modules, it's huge, and bring in the whole world. And build time performance is a problem, disk space, and everyone knows about this. Runtime performance is a little bit less talked about or thought about. This is a nice animation of CPU speed versus the caches. And if you go to RAM all the time and are always fetching your data out of RAM, you're living in this world. Your CPU is many, many times slower than it could be, and your code and your software will suffer. And you say, oh, but CPU time is cheaper than programmer time. But the real trade-off you're making often is user time. And that's why when I have to click start, I have to wait for 2 seconds for the thing to pop up, where it should be instant. So we've really regressed here as an industry. If you don't know anything about this, if this is like, what was he talking about? I really encourage you to go look into that. The fact that the way you manage your memory has a huge, huge impact on your software performance today, more so than it did 20 years ago. There are courses and stuff that I can recommend as well. This is another really neglected aspect of using libraries. You are responsible for the code that you ship. It's your problem. You can say, oh, but the library is used by everyone. It doesn't have bugs or known bugs. Someone else might have found it. But you run into corner cases sometimes because you, in your software, push the limit a little bit on something, and no one's tested that before, and you find problems. So this is an anecdote that happened to me where there was a document management system that we were selling to a customer that was paying a lot of money for it. And it had OCR, and it had indexing, and it had all this wonderful stuff. And it was basically wrapping this library called Alfresco, which is a powerful engine. But most of us there had no idea how it worked. We just take this nice black box, we hook it up, we wire it in, and it works. Awesome. We can sell it for a lot of money. And then the customer's using it. I joined the team after the fact. And it was just horrible when they hit some limit problem, there's a bug, everything's broken, and now they're angry at you because you charge them a lot of money for something that fixes their problem. But now you can't fix it. And you can't tell them, oh, you know, I opened the GitHub issue, it's their problem. It's like, no, I paid you money, you fix it, right? And other aspects like accessibility. Your website needs to be accessible. You can't tell the government, oh, my library doesn't support accessibility. They'll be like, tough luck, you know, straight to jail. You are not following the law. So it's your problem. So think about that, all these dimensions as you bring that in. So what should you consider when you are choosing a library for your project? First, you have two options. And a lot of us think like this. Writing the code myself, that's for losers. That's for people who reinvent wheels. We love to use libraries, right? But there are reasons why you might not want to take that route. First, is it a difficult problem? Or is it something you could write yourself? For me, this is the left pad. This is the etc. It's just 10 lines. Write it yourself. You will learn something. You'll understand your system better. It's not that hard. We can make a little bit more of an effort sometimes here as an industry. Another variable, of course, is how long do you have? Maybe it's feasible for you, but maybe it would take you 2 years, and the customer's not going to wait 2 years. So that's another variable that you have to take into account, right? And I'm not trying to say you have to write everything yourself. Of course, we are engineers. That's the engineering part of our job. We have to trade off ideals versus reality to ship stuff to customers, right? And then the other big question that I really don't hear many people asking this question. Is this code for a core feature of my software? If it is, and it breaks, and then it's your problem, like my Alfresco wrapper story, who is going to fix it? So if you don't know it and don't understand it, think very carefully. Even though it will save you time now, it will not save you the blood pressure and tears later. So yeah, okay, you've gone through the questions, you've made the decision, you're the engineer, you say we have to use this library, it's imperative. Okay, use the library, but now let's think about some additional options that we have when incorporating it into our product, especially for a core feature. Maybe if it's for a nice to have, like your QR code generators, like okay, there's 50 QR code generators, you can swap that out in a day, it's okay. But for core features, think about these things. First example, or option, you can sponsor the project or pay for premium support. Many open source libraries are happy to take your money for support contract. This is a case with FFmpeg. How many of you know FFmpeg? Awesome, awesome CLI tool. If it does all video formats to all video formats, it's the multimedia Swiss Army knife of the world. It's awesome. And everyone who does video uses it at some, I don't know of many others that don't. Even the ones that say that they don't do. It's a kind of a joke on Twitter that you can follow their account. But this is a case where Microsoft manager was saying this is a high priority ticket, and they file it and they say fix it, fix it. It's a high visibility product called Teams that it's breaking. It's like, well, anyway, sponsor it if it's really critical and you can't build it yourself. Think about this option. Option number 2. Understand the library code yourself. Okay, you can't write it. Read it. Think about how it works. Think about how you can build it. The anecdote I have here is a library called Liquibase. How many of you know what Liquibase is? It's a nice data abstraction library to be supporting multiple databases, and you can abstract your actions. It's really nice. But they have bugs, like everyone. And they're not as well tested as you'd like. We've run into issues over the years with them. One of the examples was the data import and export for blob fields was broken. And you can say, oh, you should be a good open source citizen and share your pull request. And I did. But it took almost a year to merge. And it's not I'm not trying to diss Liquibase. It's not their fault. I don't have a right to their time. They're volunteers. I didn't pay them money. Well, now they have a company, and I could have paid them money, I guess, but we weren't paying them money. So it's not my right to demand that they merge my pull request now. But it's my problem to fix the problem. So I needed to fork it. I needed to build it. I needed to integrate it into our build system. I needed to publish it in our internal repository. I had to wire it up to our main system. And we ran like that for a year on that fork until finally it got merged into mainline, and then we can go back to mainline. But think about that. You need to be able to build it yourself and integrate it into your system yourself. So think about that when you choose a library. Follow its documentation of it. This should be non-controversial. Closed source libraries are tricky and dangerous in some industries, and in some things you won't have much of a choice. So then you just hope that it's really good and that you never have to touch it or have bugs in it. This was I had to suffer through a UI toolkit called DevExpress for .NET. It's kind of old, but there were bugs with they had buttons and things, and it wasn't working right, and it was very hard to debug. But the final reality is that you will sometimes choose badly. You'll make a decision where it wasn't so good, where they switch out from under you, where they break, where they have bugs. So you want to think about that case as well. And one of the main techniques that we can use, which I haven't seen too much of, sometimes I have, but not so much, is isolating yourself from the library. If the library exposes types and stuff of itself, don't take that type and pepper it all over your code base. Because then when you have to rip it out, you're going to have to go everywhere and retouch it. So have something of your own, map that thing to your thing, and then use your thing everywhere, and then you can just switch it out at that point. So something to think about. You will always make a mistake. And even if you make a good mistake, a good choice, that can become negative later. How many know what this is? Yeah, good. So log4j, if you chose log4j for your Java project, no one will say, oh, that's a bad idea. You should never do that. That's an industry standard almost. I don't think I've worked on a code base that doesn't use log4j. But somewhere along the line, they grew features and they added code to pull code from the internet and execute it locally. It's like, how does that happen? I don't know. But there's some sort of feature creep that sets in. And I've thought about this a lot as we suffered through that and had to patch it and stuff. Could we have written it ourselves? How hard is it really to write a logging system? I don't know. I've really reconsidered this in the past years. Like, but we still use log4j, so maybe I'm a hypocrite. This is one that happened last year. I don't know if any one of you suffered through it. Apache Commons random utils. Who knows what that is?
I know the library.
Yeah, I don't also not worked in the Java code base that does not use that library. It has data structures. It has all these nice utility functions. And they had this random utils function that generates random strings and random numbers and all this stuff. And JHipster, who knows JHipster? It's this little framework to build microservices and stuff. And they had a bug where they would generate tokens, security tokens, to reset your password with random string utils, which you should never do. Why not? Secure random number generators are a thing. Imagine a poker game where we're playing poker virtually, and I have 4 bots. And I know that the random number generator is insecure, and it only uses 10,000 possible seed values. So now I can brute force my way through the 10,000 seeds and see which of the poker hands match my 4 bots and me, and now I know all of your hands, and I will win. So that's just one example of random number generators. Same thing for a token. I can send you password reset, and then I brute force my token, and I'm you now. Anyway, mistake for JHipster. What's the answer? They file a bug with Apache Commons, and they say, this is a problem, a vulnerability. But it's not. Like, if it's insecure, it's not meant to be secure. You should be using secure random. There are classes for that. There's APIs for that. But no. So what they did is they switched the random number generator to use the most secure. There's a mid-secure and there's a super secure that uses system entropy from the thermometer and your mouse. And what happens when it runs out of entropy, it stops and it waits for more entropy. So what happens if your system is generating random stuff? It freezes. You don't see the CPU spiking. You don't see any other problem. It's just frozen, and you don't know why. So this is super fun to debug in production. That is kind of irresponsible, in my view, to switch. That API is really old. Why would they change it like that? I don't know. I really objected. I had some strong words on my PR for them, on my complaint, I should say. But it's what it is. Even though, for me, that project has been managed well for a long time, sometimes new people come. Sometimes they think things differently. And so libraries can always be a point of risk. So just something to think about. Some other commonly neglected library metrics that I could think of. I wanted to zoom out first and think, what is a good library like? It is basically just good code. But the bar is so much higher because you've put the code out into the world, and now people have to use it, and you can't switch it. You can't send Windows updates to it necessarily. It's there and it's working. So this is the first kind of dimension that I want us to think about. Just, is the code good, and how much better does it need to be than my normal stinky code? This is a question that I don't see asked very much, and we don't think about it in these terms often. Is the code finished? What does that mean? So I've written shell scripts a good 20 years ago that are still running just fine, because the API for ls and grep are still the same. No one's changing it. I'm sure if I go to their GitHub repository, there won't be many recent commits. And that's fine. It's an awesome piece of code. It's just working. So I'm trying to go a little bit against. I'm not saying that looking at the most recent commit is bad, but I will say don't just discount a repository because they haven't committed. Maybe it's just so awesome that no one needs to touch it anymore. And it's worth it. I suffer through Ansible so much but we don't want to stay here too long. Second question, is the documentation good? Is the code easy to understand? So 2 things, documentation and code. Spring is, for me, the quintessential example of bad documentation. It's very complicated. There's a lot of stuff to learn and study, and the documentation is very surface level. It's a tutorial to do a pet website, and that's it. And it changes all the time. There are books written about it, and they're all obsolete now, because every 6 months or a year, they change everything. Once again, deprecate, deprecate, deprecate. So for your library, look at old blog posts, look at old material and tutorials. Has it changed a lot? Is it broken? And yeah, see what people think. But all these things can change, like I said. And how have they handled breaking changes before? You can look at the Internet Archive. Sometimes some websites publish really nice versioned changes and stuff and change logs so you can really see the past. But for those who don't, the Internet Archive and the Web Archive can be your friend to see what the website was like before, how much have they changed, and how consistent they are. Like the Linux kernel being like, we never break user space. That's the type of thing you want to hear. Respect my time. This is, for me, another bad example. Hibernate is you probably know what that is. It's an ORM to abstract your database tables from you. And each of these guides is huge. Loads and loads of things that they've changed and broken and that you have to now go learn to get on and they deprecate very fast. Like, see, it's like months apart and they're just moving and moving and moving. And I'm suffering through these upgrade guides. And as I look through the source code of the migration guide of 6.0, I see this. And sure enough, I have a lot more issues that are not in this list. So it's true, there are more, but no one cares. So it's not a nice place to be. The other question, how easy is it to build? So as I was saying before, sometimes you have to build it yourself, release it yourself. So it's worth it, especially if it's a critical library in your critical path that you might have to maintain and patch. Follow their build process once. See how it is. See if it's up to date. See if it's broken. And maybe open an issue if it is. And yeah. And then just build it. Just do a small integration prototype. If you throw it away, it's okay. You will have learned something. So other thing, benchmark your use cases. Sometimes we just look at a benchmark online and it's like, yeah, this is 50 times faster, but it's maybe not reflecting your load, your use case. So just run your own benchmarks. And yeah, as you follow the integration of the library, you will also look at the documentation yourself. You'll see, is the documentation good? Is it bad? And go through the code base, see how they implemented it. Is it efficient? Is it well done? So yeah. So my final thoughts about building libraries that are sometimes useful in the choosing dimension as well. So it's not bad to look at, like I said, stars and last commit dates, but there's still other things to think about. When you build a library, you won't get it right the first time. And this is really important. Why is Gradle changing their API all the time? It's because they didn't get it right, because they have some performance problem. It's because they have some thing, and that's not their fault. We all make mistakes. It's all a function of our experience. So own this idea. You won't get it right the first time. The best thing, in my experience, that you can do is write the code that solves your problem first in your code base, avoiding to write a library. Because you asked a good question, like, have you written a library? And the thing is, we all have written libraries. In your code base, when you build an abstraction, you're building a mini library. Yes, you're not publishing it to NPM or Maven, but you're building a library. So don't be overeager to build the abstraction. And I've made that mistake many times. My teammates have made that mistake many times, where we have a case coming in, a problem. Say, oh, okay, let me build the abstraction for this. Let me build a library. We're going to have a executor, an inputter, and then a processor, and this is the order. And then in a month, a new requirement comes in, and all your abstractions were wrong. You didn't think about this other use case where the order is different. So it would have been much faster and easier if you just wrote the sloppy code that gets that job done, do it 2 or 3 times, and once you've seen the implementation and the problems from several angles, then you maybe have a shot at getting a better API that you won't have to change, that you won't have to break your user's code with. So, yeah. This is a real problem in the industry as well. Like I said, if you get it wrong, you have to fix it, you have to put out patches, you have to rechange all your API. So that means that the first time they did it wasn't well experienced. So you can also do it better by just practicing and solving the problem several times. This is an idea that has really been on my mind. Someone said it, and it really stuck with me. your API is a promise. And if there's anything that you take away, I would like you to take this away. Your API that you built is a promise to the future. It's a contract that you are fulfilling. And if you break it, there are penalties. Maybe not immediately for you, but there are penalties for your customers, for your users. There's loss of trust. So getting that API right matters. So all the more reason to practice, solve the problem in many ways. Don't flee from writing code. We are programmers. We should be writing code and not publishing everything as a library on our first try. Backwards compatibility is really important. And yeah, once again, minimize your dependencies. I firmly believe that the zero dependency libraries are the pinnacle. They're the best thing. You love them when you see them, but it's not always realistic, and that's fine. Many great libraries like curl and FmpEg have dependencies, but minimize them and don't break your API. So yeah, another thing, if you build the library and then you see that maybe it's not as nice or as polished or as perfect as you would have liked, it's not a bad thing to just build a new one. You will take all that experience with you and make something better. But don't necessarily think that you have to go and rip apart the first one to make it better. Sometimes people love it and are using it as it is. So don't discount that thought. Maybe just build a new one. So yeah, let's all become better programmers. Let's practice. Let's write more code. Let's make faster software as well. That's a real pain point for me these days. But yeah, thank you. Any questions?